For activity 7.2, you will have to create, not create, but you have to download an app that's called GeoGebra. So let's read it. It says the lifespan of light bulbs is approximately normally distributed. Some statistics about lifespans of two different types of light bulbs are listed. LED bulbs have a mean of 2,300 days and a standard deviation of 230 days. Incandescent bulbs have a mean of 100 days and standard deviation of 10 days. So automatically, right here, you need to know that this is a normal distribution. So you should start thinking about mu plus sigma, mu minus sigma, and so forth, right? So we have a normal curve here. To estimate the proportion of bulbs that burned out in a certain interval of time, use technology to find the area under the normal curve and above the appropriate interval. And they give you here a scenario. Estimate the proportion of LED bulbs that are expected to burn out before getting within one standard deviation of the mean, or before 2,070 days. So automatically, you know that because the mean for the first LED bulb is 2,300, then we're going to add 230 to get the first plus sigma, but we're also going to subtract 230 to get the minus sigma. So that's where these numbers are coming from. So the first one should be within one standard deviation below the mean. 2,070, and then the other one you just add it up, so it should be 2,530. Okay, so how do you do this? I'm gonna exit from here and I will go to GeoGebra download, and I'm gonna type here classic 6. So we're gonna download this one. And then just give it time here to download. So you're gonna go to geogebra.org/download, and then this is gonna show. So you're gonna click on GeoGebra Classic right here. I already downloaded it, so that's why it doesn't show. Oh, I'm sorry. To download right here. Well, I already downloaded it, so I'm not gonna do it again because it took like 3 minutes. But anyways, you download it, and then this is gonna show. You open it, and then this is a graphing calculator. Okay, so for those of you who don't have graphing calculators at home, this is a graphing calculator. You just need to learn how to use it. You can move these around as much as you want to. If you're a math major, or if you're thinking about becoming an engineer, there's a high chance that your professors are going to ask you to be knowledgeable on how to use GeoGebra. Most professors of higher math classes, they either use this or a graphing calculator or some other program. So you're gonna click here, and then you're gonna go to view, and then you're gonna click on probability calculator. So as you can see here, you have all these great settings here, so you can use it to the best of your ability. Alright, I'm gonna make this bigger, but you can make it whatever. And actually, you can download this in your phone as well, if you don't want to do it in the computer. So this is what you see. And remember, mu means what? Mu means mean, and sigma means, that's right, standard deviation. So the only thing that you have here to do is to go back to the problem. And then I'm gonna do only 2 problems, and then I will let you do the rest, okay? Because it's pretty simple. You just have to input the information and then move it around so you can see what's the area under the curve. So the mean in this case is 2,300. So I'm gonna go back here. I'm gonna put that as my mu. And then the standard deviation is 230. So 230. There it is. It's gonna generate here these numbers, and that's fine. I mean, even though we have a lot of numbers here, like you don't need all these, but it's fine. You know how to change it. Now we go back to the question. So in this case, they're asking you to estimate the proportion of LED bulbs that are expected to burn out before getting within one standard deviation of the mean. And they tell you there exactly what it is before 2070 days. I think we already covered why they got that number. Okay, it's mu plus sigma, mu minus sigma. So it's right here, right? That's the within one standard deviation, but that's not what they're asking you. It says before getting there. So what I'm gonna do is that I'm gonna move these all the way here. Okay, you can keep moving, it doesn't matter. Once it reaches these here, it's already at the bottom. But it says that I need to get before 2070. So I'm gonna move here my other arrow, and I'm gonna just look up here, what is that? And I'm gonna stop where it says 2070. It has to be before that. Okay, so if I leave it there, it's not gonna be exact because it has to be before. So that's exactly on the 2070, but I want it before getting there. So let's see if I can move it just a little bit more, and I should be able to. Okay, a little bit more, a little bit more, a little bit more. Let's see. Okay. It seems that that's the, it might be very different for you because I tried this before and it did give me the answer that we are looking for according to the book. But if you're not able to get the answer provided by the book, it's fine. I guess it moves every time slightly different. But that's all I can get here. See? Yeah. I think there's a way to like maybe adjust the settings on how much the slider is moving, but this is good enough. So in this case, I'll go back here and my answer will be, for some of you, your answer might be 0.1578. But for me, it was 0.1565. So that's close enough. Okay, let me see if I can move these a little bit to this side. No, it doesn't really matter. I cannot get farther than that. Okay, that's good enough. There. So that's the answer. So it would be 0.1562. Now let's do the other one. It says estimate the proportion of LED bulbs that are expected to burn out in the interval between 2 standard deviations less than the mean and 2 standard deviations greater than the mean. So if you think again of that empirical rule, we have mu plus 2 sigma and then mu minus 2 sigma. So, but they're telling you here exactly what number that is. So you can just go back and do that. So let's do the first one, 1840. So that will be there. And 2760. So So 2760, that will be there. Okay, so for this one will be 0.9545, and that will be the area under the curve between the exact interval that they're asking you here. So I'll stop here, and then I will let you respond in a survey the rest of the problems.